The PDB Reader is a required module whenever your builder workflow involves a protein structure. It provides the essential first step for preparing a protein or protein ligand complex prior to system construction. In this demo, we introduce the advanced options of the PDB Reader. Since there are 14 options in total, which can be difficult to explain all at once, we will instead present examples to illustrate each option in detail. We have already demonstrated the basic usage of the PDB Reader in a previous session. Here we will begin from step 3 to highlight the advanced options. If you need instructions on the basic functions, please refer to the earlier demo first. In this case, we will load the 7F55 PDB, which contains the human melanocortin-4 receptor MC4R bound to a peptide agonist and a heterotrimeric G protein. After loading the PDB, the blue highlighted options are automatically activated. By default, 5 options are enabled, and we will additionally enable the mutation option manually. 1. Chain selection. The PDB file includes 6 protein chains, along with ions and water molecules. Note that chain F is the Cyclicpeptide lig and bound within chain E, MC4R. In this demo, we will load multiple protein components together with the Cyclicpeptide ligand. For ion and water chains, you can select properly. We will deselect the options. 2. Model missing residues. The PDB Reader can automatically generate missing residues in each protein. Most options are suitable by default, but Prote A requires special attention. Modeling more than 10 consecutive missing residues may result in an inaccurate structure. Therefore, you should deselect residues 75 to 204. When you deselect residues, the terminal capping options will appear. You can then choose from several capping options. In this case, we will use the default settings. Terminal capping is applied to stabilize the exposed N and C termini, preventing unrealistic charges and ensuring a more physiologically relevant structure. 3. Disulfide Bond. If the PDB file contains disulfide bond information, it will be displayed by default. You can either add or remove disulfide bonds as needed. To add a new disulfide bond, select the protein and the residues you wish to connect. 4. Non-standard amino acid, RNA substitution. If the PDB contains non-standard residues, this option will be activated by default. In this case, Prot-F, the cyclic includes a non-standard amino acid NLE. You need to map this non-standard residue to an equivalent predefined standard residue in the force field. You can either select from the drop-down list or use the search function. When you click the search button, the residue details will be displayed. Since there are over 300 non-standard amino acids available, you may either browse the list or search by residue name. After confirming the residue, click Apply. 5. Terminal cappings. In this option, terminal capping is applied by default. However, in this case, Prot-F, the cyclic peptide, must retain its cyclic structure. Therefore, you need to select the cyclization option for Prot-F. This ensures that Prot-F is correctly recognized as a cyclic peptide. 6. Mutation. The MC4R protein has several mutation types. Within the PDB Reader, you can modify residues to introduce specific mutations. In this example, we will generate the S188Y and Y268I mutations. The MC4R protein is assigned to Prot-E. Select Prot-E, then choose the residues you want to modify. First, select residue serine 188, then replace it with tyrosine, TYR, and click Add. Second, select residue tyrosine 268, then replace it with isoleucine ILE and click Add. After setting all the options and clicking Submit, the generation begins. This process takes some time. Once the generation is complete, the cyclic peptide is created and can be properly recognized in the PDB. This PDB can then be used for various studies such as MD simulations or free energy calculations.